This is a quick mini lesson in between our work on the EC2 instances. Usually when deploying EC2 instances, we use SSH to administer them. If they're in public subnets, we can SSH directly like we did in our example. Here's us opening an ingress rule in the last lesson that allows public SSH access to port 22. If the app servers are in private subnets, we create a bastion host, an SSH server that sits in the public subnet like this one did, and has access open as a jump point into the secure and hidden private subnet hosts for the app and database serving. What used to be a best practice, though, has become an anti-pattern. You can see there's articles like this one. Goodbye SSH, use AWS Session Manager instead. Hello AWS Session Manager, farewell SSH. Instead of allowing SSH access to our instances or deploying that extra bastion host, we can now use AWS Systems Manager to connect directly to our app servers no matter what kind of subnet they're in using our AWS credentials. For me, this has one huge benefit. I can manage access to that server using IAM credentials and user management built into AWS. Using SSH or SSH with a bastion host, I was always passing around an SSH key among the staff who needed access, or putting the time into generating separate users and SSH keys for each of them. So there's a lot of security gaps in that. Passing around an SSH key among your developers and staff is a big problem. You need to be able to revoke that key when someone leaves and issue a new one. You're managing who has access to it. It's possible that it's been passed around without you knowing. You don't have transparency or control. Using the session manager, there's a lot of benefits. We have full control over who's connecting, and there's a lot of built-in logging right into the session manager. We're going to update our CDK code to install the session manager agent on each instance when it boots up so that we can access it. And we're going to have to assign it a role so that it can access other services and be accessed by other services. It's a good practice to assign a different role to each class of instance, to each type of instance that you're launching, so that you can later assign them permissions and capabilities to access other AWS services. We'll do that through the IAM module. So first of all, let's install this. Good. Now we can import that. I'm going to cut and paste a little bit because you don't need to watch me type everything in here. So down here where we create our user data, this installs Nginx and enables it. We're going to install the latest Systems Manager agent as well at boot time. Now, if we look over in the AWS docs here, this is the docs for AWS Systems Manager. There's pages that describe how to install and configure it. This one's called Manually Install SSM Agent on EC2 instances, and it gives you down here the command lines to do the install on the custom RPM. So if we were to do some cut and pasting from that, I'm going to borrow from my existing notes here. After we install Nginx, we're also going to, here's the URL from the doc page. We're going to do a yum install on that RPM URL and then restart the agent to make sure that it's running. Great, so that's going to install the packages that we need to expose this instance to being managed by Systems Manager, which has a lot of other benefits down the road as well. And then let's create a role. Again, we'll speed through this a little bit. New role, we've given it our normal naming scheme, assumed by EC2, service principal. Now this role is empty. It doesn't have any policies or permissions attached to it yet. So again, copying and pasting from some of the documentation for Systems Manager, I'm going to attach the managed policy. That means like the default AWS policy that they've created and released, SSM Managed Instance Core. That's fine. That's all we need is to assign that policy to the role that is used by our instance. Then, of course, we just need to assign the role to the instance. Now, this is interesting. I've seen this before. Type role is not assignable to type iRole. Well, it is. I'm not actually wrong here. I bet if we look, because I just installed that AWS IAM package, I bet there's a bit of a version mismatch between the package that I installed today and some of my other existing CDK stuff. If we open up, let's just go confirm this. Sorry, scroll. Package.json. Let's look at our CDK. Yeah, look, we have a couple different versions happening right here. My IAM that I just installed is version 133, And when I was last working on this EC2 example, that's 121. So the problem is that there's a bit of a difference between the object defined in version 133 of this role and what is required by version 121 of this instance package. So this is a quick fix. You'll see this for sure in your work in the CDK, that something is not assignable to something else when you're pretty damn sure it should be. So I'm just gonna do an npm update. Good, done, things are up to date. We can see here that it updated so that everything's 133 now. CDK core 133, CDK assert 133, CDK EC2 133. And this should disappear. You know what? Let's do a quick... Let's start our watch task on it to make sure there are no actual problems. Found 0 errors. So even though my type hinting is still causing a problem with that, there are no actual problems. There. If I close and reopen the file, it's fine. So that's done. We've got our new role. We are installing the SSM manager. Let's now just clean up some of our code a little bit. Let's take away this SSH access that we used previously. We're no longer going to have port 22 open. That's great. We've improved our security by 1 notch already. And then let's take away this key name. We don't need to be giving it an SSH key any longer in creating this stack. So let's take that out entirely. We don't need to manage keys anymore. Now there's one more thing I want to do. It gets a little tiresome having to check the web console for our instance details so that we can see the public IP, etc. So after we create this instance, let's output the created instance information. Let's put the ID and the public IP out in the console after we run deploy so we can see what got created. There's a documentation page for this right here in CDK core. Right here, CDK core package, there is a CFN output function, which correlates to the output resource on a CloudFormation template. And all this is going to do is output information for us. You create the CFN output resource, construct, in your code if you want to see stuff output to the console. So you can give it, and then the output props define the value, you can give it descriptions, you can define names for it if it needs to be reused by something else. But we're going to keep it simple. And again, I'll paste in from my notes right here. So we're going to create these 2 CFN output constructs. They are scoped to this class. I've given them nice names, the instance ID and the public ID. And then for the value of each in this anonymous object where we're passing in the properties, the value is the instance ID field and the instance public IP field. Now, as always, you can find out what you have available by just using your autocomplete. So here, instance public IP. If I wanted to also add the DNS name for it, because I want to use there, done. Save that. Let's save everything and let's go deploy. It's also complaining now that my CDK is out of date. So I'm going to do a quick update on that. npm install global CDK. You can use this either to install CDK on day 1, or you can use it to update at any time that is needed. Done. There, done, cool. And you can see the outputs here. Instance ID equals I dash blah, blah, blah. Instance public IP, 52.53, etc. And our instance host name is this DNS name automatically assigned by Amazon. So this is a lot easier than us having to go to the console every time we want to check on something. We can actually jump to the console though and see that here's our app server, relaunched. There's the old one, there's the new one. If we check our security groups here, we can see that the inbound rules do not permit 22 anymore. And so if we go back to our terminal, let's actually connect to this using the systems manager. AWS CLI, we'll specify our profile again. SSM start-session. And for target, we give the instance ID right here. And if we've done our jobs right, this should give us a secure shell on that instance, even though it does not permit SSH access through port 22 publicly, and even though we do not have an SSH key specified anywhere in this. It's done securely through our credentials with Amazon through their backend. Done. We're in. And if we go look in the session manager itself, here under managed instances, we can see the instance. We can see that it shows up here in our inventory. It's online, it's Linux, it's using this AMI, it shows us the platform version and agent version. This is going to give us a bunch of new capabilities. We can leverage the systems manager tools to control the inventory. We can do automatic updates. We can take actions across entire fleets. And from the session manager here, we can see a list of the sessions that we've launched on that instance. We can see a session ID, an owner, a start date, etc. So we have a lot of auditability done automatically already on these console sessions without configuring anything extra. So there's a whole list of benefits to using SSM instead of SSH, and you should really make the switch. If you need audit logs, if you're working in PCI or secured environments or HIPAA, I'll put an article in the show notes that has instructions on piping these console logs to CloudWatch logs or to S3 for cold storage and analysis. Let's keep going.